I'm not really sure what I'm gonna do today, but I think I'm going to. I changed my mind on the idea of cleaning up static variables or static string names on Godot, and I think I'm just gonna ignore the warning there. So I'm just gonna remove the stuff that I did, then change the warning message, change the condition for the warning message, and then put it a comment or change the message itself to specify that the engine is not cleaning static string names for now. Then after I do that, I'm probably gonna study assembly. So I figure out or realize that you can change the sconstruct file on the Godot project to put these flags here, and this flag generates assembly code. It breaks on a third party module, I think, or this module here because of the permissions, but I don't care that much about this. I just want to see, like, spend some time reading the codes, and I also have this other stuff here, which is an emulator that you can use that I got. I'm probably gonna search for other code examples as well. We have this as well here. So I'm just gonna look into these codes, and then I'm going to maybe I'll do Anki cards as well to try to memorize the registers and stuff like that. And I might study the other stuff from Godot that I have to study to implement next. It's gonna be the pop-up menu that shows up. Like it's gonna be something. I think I'm just gonna focus on the stuff that I'm doing now. So we're just gonna focus on one scene and developing components to this scene. Yeah, it's pretty nice. Then you can emulate here and can go over the steps to see what is going on. I think I accidentally closed the thing. Let's run again. Interesting. The hardest part about assembly is that, like, understanding. I'm gonna think about this as well because I think the main question that I had was about the addresses. So the thing is, everything works on register and memory. Like a program is basically just changing memory on a computer based on the instruction set architecture, which are the instructions that are supported by the hardware architecture. So the thing that is kind of confusing to me now is about the relationship between addresses. So how do you think about the addresses when you code on assembly directly? Also, the other thing that is interesting is to probably this is actually more interesting to use the compiler explorer to see how to study how this like simple C code is compiled into assembly. I'm probably gonna do this now. And I'm gonna focus on the x86. Not sure which compiler though. Probably Clang is fine, sure. I think probably Clang. I'm not really sure if it's gonna work if I put Clang. See this one, nice. So let me just gonna remove the stuff that I did last time. This stinger. The way you put the flags just depends on the compiler you're using. I just did the easiest version possible. To just check for the MSVC thing. I downloaded the latest stable version, which for some reason is not working when I compile. It just works when I have the executable. When I download the executable directly, then it works. But if I compile and I try to run the project manager version, it doesn't work. And I didn't spend time to try to understand yet why this is going on. Basically, all I have to do is just you append the C flag, this one, and if you're using MSVC compiler, then you append the C++ flags, append this or prepend this flag here, and it's just going to generate the assembly code for the files. The problem, obviously, with understanding this is that you have to find the entry point, then you have to find a bunch, have to like organize things. And you can use these other programs, which I might try to use now as well. I think it's IDA. I'm not really sure how to pronounce them, but this IDA is one of them. Then you have GIDRA, which comes from the National Security Agency, NSA. And as far as I understand, you get the executable. I was using Anki because Anki is open source. And it allows you to create the graphs of control flows of the assembly to connect the functions. But I didn't spend time yet to like do stuff with this yet. It asks for this for the symbols, I think. This is basically the code, I think, from Anki. So they get the executable and then they probably reverse engineer based on the instruction set architecture of the hardware, and then they're able to get the assembly because assembly is just binary. So based on the standard of the hardware, you have the binary that is going to represent each instruction. The cycle of instructions are going to be a finite state machine that is encoded on the hardware. That is, and the like everything that the programs are is just basically a finite state machine running in an infinite loop according to the instruction set architecture, which is how they manually encode the logic on the hardware to have like the gates that are gonna perform the computations based on the whatever logic units you have for different computations, which is gonna be arithmetic logic unit with some variations depending on what kind of hardware it is, and then different hardware components are gonna have gates that are gonna have standards that allows different manufacturers to synchronize different components based on ports. So the memory goes around based on the control logic, which is the CPU. And so all the programs are going to be basically a variation of the assembly instructions that change the state of memory that produces different images on the monitor. So as far as I understand now, this is basically you select the executable, then the program reverses engineer based on the instruction set architecture, the assembly commands. And I think there's more complicated, probably not actually, because it's probably selecting everything based on the labels. So there is different jump instructions on assembly to differentiate from function calls to if-else instructions. And the main difference is that the function calls are going to be a jump instruction that keeps track of the return address. So it's a jump and link instruction. And the branches are just based on calculations. So we have It's like a range that goes from below 0 equal to 0 to greater than 0. And then based on these calculations, you're gonna have the stuff. And the challenge is the nuances of the, which is probably something I'm gonna reinforce in our study, which is the buffer overflow, stack overflow, heap overflow, integer overflow or underflow. And those are the things that are very annoying to memorize because obviously you have to convert. This is kind of the annoying part. You have to convert the hex address. I think most of the time everything is going to be done with hex addresses. Then you're going to have to convert them into either binary or decimal to make sense of them on your mind. And the problem is that with the most tutorials and resources, that is very hard to, because it takes a lot of complexity to build a program that actually prints something to the screen, or not print something to the screen, but like for example, uses the GPU and the drivers and all this kind of stuff, complex stuff to draw stuff on the screen. It's hard to bridge the gap between the actual program that shows the stuff on the screen and what is happening on assembly. So it becomes harder to understand how all the interrupts and all the stuff that happens to make the monitor print stuff on the screen. So the connection between the memory addresses and how that actually translates into information on the screen is very hard to clarify. But what is showing here, as far as I understand, is just it's creating a control flow graph, which is the way that the compiler is going to build the connection between different jump instructions, which is basically the fundamental principles of programming, I think. Like all the programming is going to be a tree of information. So you have like calculations, which is just like mathematics, and then you have the branching, which is just changing the addresses in memory. And everything else is going to be abstraction built on top of that. So the most primitive, I think, abstraction is just going to be the control flow, which is just a graph that keeps track of the branches of the computation. And this makes it easier to visualize, I think. So it's basically just encapsulating the scope, which is just how different branches are going to change over time. And I think that you have the main one, and you also have sections on assembly, which is the way that the program is going to be organized into the hardware, or it's like an abstraction of what's happening on the finite state machine on the hardware. So dot text, the segment, I think is all the segments that have the instructions. And the dot data, I think, is when you manipulate memory, but I'm not really sure. I'm gonna ask probably ChatGPT or Perplexity to clarify these things, but I think it's probably that. So that all the programs are gonna be basically the same pattern. You have the stack that grows down. So it starts on high addresses and goes to low. Then you have the heap that grows up. The heap is larger than the stack, and they're both dynamic memory. So, and then you have the tags, which is the instructions of the program, and you have the data, which I'm not 100% sure yet how it works. I don't know, so I'm gonna ask that for first. What is the distinction between dot tags and dot on X? Apparently most of the code is done with x86 assembly, so LLMs are more likely to be better with x86 than with RISC-V. RISC-V is more for embedded systems, and x86 is more for personal computers and stuff like that. So x86 is the one that is used the most. And RISC-V is for the embedded systems, and the ARM, I think, is also for embedded systems. Yeah, so data segment stores variables. I think this semicolon is for when you want to put comments. Keyword, I think, is just for 64 bits, and the words for 32, I think. So because of the way that everything evolved, the word is going to be 16 bits, the double words 32, and I think keywords 64, but I'm not 100% sure. I'm pretty sure is what is going on. So it looks like here is just declaring some variables on addresses in memory, or as addresses, but I'm not really sure. It pushes a pointer, I think. So this RBP, I think, is register base pointer. RSI, I don't remember. This is kind of the annoying parts, like memorizing all these different registers. And that's the reason why I'm thinking about creating the Anki cards, because the ones that I have there is not very good. They have, like, I prefer the kind of cards you have to type the answer, or that are gonna have some. I'm not really sure which one should do in the beginning. Not sure if I should take a program and there's, because doing Anki cards of images is very easy. I think you just take the image and then you put there, and then it allows you to build a bunch of cards at the same time. So it might be better to just study the programs first, a simple program, and then based on that, say no, or maybe using the compiler there first, the C compiler. I think the main question that I have is, so as I do this, I'm gonna think about questions and I'm gonna try to clarify them. So I think the main question, the thing is kind of hard to put into words, but it's kind of hard to phrase the question. But what I'm thinking about is how do you, what is the reason why someone that builds stuff the way that they do? Why would they choose specific addresses? Either the compiler or the person building the assembly directly. Because what you're writing on the assembly is not going to be it might not be the RAM address. Most of the time, I think it's not the RAM address. There's a bunch of logic that happens from the address that you're using there to the actual physical address. Because there is a translation between the stuff you're writing from the program and all the levels of abstraction that are going to allow you to use different places in memory on the hardware. And on top of that, use virtual memory as well. So I have to, on top of like synchronizing between all the processes that are running and all the places in hardware that you have different places in memory, you have to also translate those places into the physical address by working with the virtual memory mapping. So it gets very complex to understand. So like from my perspective, like I'm thinking, what is the reasoning behind someone putting a specific address when they are designing a simple program at the beginning? Like, why would you put X, whatever value? Why would you push that and pop and stuff like that if you don't have a very clear map? If it's impossible to have a very clear map of how the address is going to be translated into the hardware and how that's going to produce whatever results you're trying to achieve. How do you think about this? Because the addresses are relative as well. So they randomize the addresses in the beginning to make it harder to exploit. But the problem is, if I ask like this, I think I'm not gonna get very good answers. And these cards here are not very good. I'll go back to this. Sometimes it breaks the thing to go back there, I think. Just have to close and go, yeah. I'm just gonna ask. I think one interesting thing might be to search for the problem is like as always it's gonna be hard to find the range. So up until a certain range it's possible to just see with the compiler, I think here. But then after that, when you need the problem is the building process. Like at some point you're gonna need a compilation tool or like a linking tool to put like libraries together and stuff like that. And the more complex it gets, the more like the harder it is to see the connection. But I think probably a good thing to search in the beginning is something related to sockets and networking protocols. If it is possible to find one that is very simple. I do they do allow here some libraries, but obviously imagine that they're not gonna have a bunch of them, so probably the standard library they have. So I guess I could search for like simple socket connection protocols if there are. So on x86, when you use the square brackets, it's like dereferencing a pointer, just getting the access, you're accessing the value from that memory address. And what is happening here is pushing this base pointer to the stack. Then is moving this memory to the base pointer. RSP. It moves the value. I think here it decreases the pointer because it's moving this stack, I think. Or each instruction is gonna automatically move the stack pointer down by one instruction, unless there's a jump. So I think that's what this is doing, but I'm not 100% sure. I'm gonna ask the LLM. But here I'm pretty sure that it's just pushing and popping at the end of the function, the base pointer, and then it returns. So this is probably the pointer that moves the stack, and the other instructions are just moving the value to the register. This is multiplies the value. I'm gonna, as I do this stuff, I'm going to compile. I think I'll probably remove the stuff that I put there. Then I'm gonna compile and see if it runs the way that it was running before. The only thing I'm going to change is this condition there. So like, I, I think I'm gonna keep. I was thinking about doing both of this, but maybe I'll leave the problem with the condition the way that they did is I think I understand the reason behind why they did this is that like if you think about it, static means that you want the variable to live throughout the execution of the program, so it doesn't make a lot of sense to clean the static string names. But you also want to keep track of how many static string names you have and how many normal string names you have. Because it's just good to know, I think. But the problem with this obviously is that it's very misleading because if you're not gonna clean the static string names, then when you're putting here, like it makes people think that you're supposed to clean the static string names. That makes sense, at least from my perspective. So this is kind of the issue. But I think that just leaving the old condition and then just changing the message here so that it says that static string names are not clean yet, then it's probably, and maybe it puts another comment to make it more clear that the message only shows whenever there's a difference between the amount of static string names and the amount of uh, known static string names, because the known static string names are the ones that you're supposed to clean. But yeah, I'm gonna wait to clean this. So once I fix the warning, I'm just gonna move on to the other stuff, and maybe later I'll come back to try to do this. And the main reason why I decided not to do it for now is because I've seen on a comment somewhere that it seems that declaring declaring using dynamic things that can change on memory with the words static it might be an anti-pattern because of multi-threading. So, and I'm not 100% sure if that's true or not, but I think it just makes sense because of the nature of multi-threading and static variables. So I think that's like it is possible to use, but it just increases the likelihood that someone is gonna make a mistake. But I'm not 100% sure if that's the case or not. So I just read on the comments. So I think that there is a degree of truth there. And it's not that the memory on the static is being changed. So as far as I understand now, the way that it works when you use the static keywords, it's going to assign a place in memory for the variable on the either I think it's probably going to be on the dot data of the program. So it's not assigning either on the stack on or the heap. It assigns on the dot data, which doesn't change throughout the execution of the program. So it assigns the data for the variable, but that's not the data that is going to be assigned during runtime. During runtime, what's happening is that it's going to use that variable, which is assigned on the dot data, to allocate stuff on the heap or on the stack, I think. So it just uses the data for the variable as a reference. So, for example, in the way that I was doing there, where you assign a static vector, what's going to happen is that the compiler is going to assign the data for the variable in the .data section of the program, and then throughout the runtime is going to assign stuff on the heap or on the stack, which are the pointers, but it's probably going to be on the heap, which are the pointers that I was using to keep track of the string names. And I think because of this, because of this, and because of all the travel path of uh, the memory flow, let's say, the data flow between memory places and the different threads of the different processes accessing data at different times, it increases the chances you're gonna have a data race. But the actual problem that I had there was just a dangling pointer because, and I understood that in the beginning as well, in the first time, because of the way that I was doing things there, because I was assigning the wrong string names. But it is also like something that's, even if I fix that, it's kind of it was a problem that is annoying to deal with because of the constructor. So like there isn't any obvious way to couple the static string name creation with the class instance itself. So you can do it through the macros by putting the logic on the macros, but then it becomes kind of annoying as well to keep track. But and there's also always the risk that you're gonna have the situation where I have the dangling pointer because of whatever reason or because of different trends. I think that's kind of the issue that he was talking about. That's kind of why it's considered an anti-pattern, because increased likelihood that you're gonna have dangling pointers, because it becomes harder to prevent data races by putting either using mutexes or putting locks. Even if you have a situation where you are using the STD atomic on these operations on the string, I think it comes down to the coupling thing, because if you build the class structurally to use STD atomic, which would prevent data races, because you're using static on the class, you have to decouple the creation of the variable or the manipulation of data in relation to the variable and the structure of the class. And that gradient of decoupling makes it so that increases the probability that you're gonna have data races, because you can't enforce the locks and the atomic because they are gonna be on the boundary or on the grade on the gap between the static and the structure of the class. That's probably the reason why it's not very good. So I think it does make sense, and I think it probably is an anti-pattern. So, but probably one solution would be to just do it from the memory here, or like, because the warning doesn't matter that much. It's more about just letting you know that there are static string names, and that's kind of the reason why it's kind of weird, because it's letting you know that there are static string names, but you're not supposed to clean them. And you could clean them here, but then what's the point of putting them on the message? I think the probably the best solution is just to compromise and just to change the message. So I'm gonna ask ChatGPT. I'm gonna start with this one. See what it says. So this is stack pointer register. I'm going to write down. Next thing I'm going to ask you just about this. I think that the main thing to do in the beginning when you're learning assembly is to memorize what registers are used for what and which ones are used most often. Because you're just going to follow the Pareto distribution because most programs are the same. So in the beginning, you want to memorize what are the registers that are used most often. That's what I'm going to do. And I think that they're all. I'm pretty sure that like the different types of registers are always going to be the same regardless of which program you are using. And it's not like the computer only has those registers, is that like it only has those types of registers, but depending on the architecture you're going to have, it's just the quantity that changes. So it's always using the same types of registers, but you can have multiple different processes with the same types of registers. And that's how you have multiple different programs running at the same time because you have different processes. Different processors are just different hardware architectures that are going to deal with data. So and this is the thing that I learned about concurrency and parallelism as well. Concurrency is when you have the same thread changing between tasks, and parallelism is when you have different threads that can may or may not be working on different tasks. It's like it's not the same, and it is kind of like a superset, but I'm not 100% sure. But I think usually what is happening is you have at least concurrency you're gonna have, because you're gonna have the same processes working on different places in memory, obviously to optimize. But I do think I don't remember really well if it is. I do remember there's something about like from the lecture that I saw from the I think honor. It's gonna be the scalar execution from the I think from concurrency and parallelism, but I don't remember really well. If it's, I do remember he says they are decoupled, so it can have like the decoupling I think is with out of order and in order. Yeah, that's the decoupling. So you can have in order scalar or superscalar, and then like vice versa. They're not coupled with each other. But I don't remember if that's related to concurrency. But I think it has to be because it is a form of concurrency. So superscalar hardware is a form of concurrency on the data path because you have multiple instructions running on the same cycle. But that would be more parallelism actually. Yeah. Obviously just concepts, and it's more important to understand the fundamental, I think. But I think usually what is going to be happening in most hardwares is that probably you're going to have superscalar execution and you're going to have out of order execution because that's the best way to optimize. So you're always trying to optimize how much work you do for, per clock cycle while simultaneously decreasing the price you pay to build the logic circuits. So that's how the hardware is going to be. From fundamental principles, that's how it's going to evolve. Which means that most likely most of the time you're going to have either one process is executing multiple different instructions like at different times. So you're just changing the place it's kind of like you are on a restaurant, and the thread's the person that takes orders, and then it goes to the chef and tells the chef what to do. So it's like the same thing. The thread's going to take a task and it's going to send to a place in memory, and then right after it does that, it's going to start working on something else. And then because we're going to have multiple different threads working at the same time, we're going to have different threads working on different tasks. And how much work they can do is going to determine on the data path, on the data dependency, which is what forces the cause and effect relationships of the program. So even though most situations are probably gonna have the same registers for like the same concept of registers for different processes, and the synchronization between them is gonna be based on the control logic. So this is why the question that I have, and I still kind of have, is like how do you reason about the abstraction you use to build assembly programs, having in mind the complexity of the translation, because you need to have a standard. It's the same logic between the instruction set architecture. Whenever you have different parts of the system that are going to be built from different industries, you're going to have a standard to create synchronicity on the network. So standards are synchronicity on the network of computation. So that means that if you have this range between the address you use on the abstraction, so like people that are programming are going to be different than people that are building the hardware, so you need to synchronize both. So the people that are building the programming, it's not possible for them to always use a different address depending on unless you have the standard. So how do you make sense of the addresses you're using on the abstraction that is the program, and how they're going to be translated into the hardware structure if they are being done at different points? How do you synchronize them? Is going to be a standard. That's the thing that I think I have to clarify. And this is the thing that is kind of hard to think about. But I think that those standards are probably usually done through the compiler and the compiler optimizations. So maybe that's the best path of exploration. So the question would be, how do compilers It's going to be compilers and linkers as well. But the problem is that it's kind of hard to think about the clarification. It's not really exactly how the compilers. It's more about the path of travel from the abstraction of the program to the hardware architecture. Like how to clarify the range of complexity from the polarity. So one end of the spectrum, we're going to have the geometry of the hardware. The other, we're going to have the geometry of the program, which is just the distinction between imagination and space-time, I think. So ideas are the abstraction, which is imagination, and the space is computation, and they're connected through time, which is a fractal. So it's going to be a cycle. And the complexity is going to be on the range. So this is the reason why on computers, like computers don't think in binary, they use binary to think. And the complexity of the geometry of space-time is going to be the fluctuation of the binary decisions, which is the tree of information. So I think the path to learn is to understand, clarify how the complexity works. From one side of the spectrum, we're going to have the abstraction of the program, and then the other end of the spectrum, we're going to have the complexity of the hardware. And then to bridge the gap, we're going to have the synchronization of the network of human beings, which are the standards. I think probably what usually happens is that the register is going to encode the relative addresses, and the actual addresses and the translation between them is going to be done by the control logic of the processing unit, which is the die, I think. The thing is, based on the videos I was seeing, the stuff that I was reading, I think it is a lot of the times. I think when you're going with the over with GDB as well, you're like it's gonna show addresses, but I think it probably doesn't matter. So if you're trying to reverse engineer from the binary into the assembly, we're gonna use addresses. And the question is, probably you have loss of information. It's kind of like the same reason why it's different. Like the way you go from one place to the other is different. You just lose entropy, I think, or increase entropy on one way, and you decrease entropy on the other way. You're generating information. So this goes into another stuff, which is the branch prediction thing. So branch prediction happens both on the hardware and on the software, but I think it's harder to do it from the software. But it's harder. I don't remember exactly what the trade-off is, but I know that on the hardware is going to be static because it's done at compile time, I think. So like yeah, you're gonna hard code the branch prediction on the hardware, so you're not updating on runtime. And then on the dynamic branch prediction, you're updating on runtime. So it's kind of like machine learning, where based on the data you do, you can do like reinforcement learning, or you can do like gradient descent to optimize based on the runtime of the program what branch should take. So the question obviously is going to be, so if that's the case, then like, but it might be done through the register. So I think it has to be both. Like the hardware is going to have control logic built into it to create the flow of the data from the register to the memory through all these different processes. They have to take into account the variance of the hardwares, which can be USBs or other memories that can be dynamically installed on the hardware. So you can remove or add RAM, for example, or different USBs and different things. So in order for the hardware to be able to deal with this, the CPU has to have the control logic of the flow of data from these different processes, which are going to work as black boxes. So we're going to have different parts on the systems that are going to manage the flow of data. So the CPU has to have some control logic to deal, but I think it's probably, and so I think the compiler is always going to interact. It doesn't interact with the addresses directly unless you're debugging, which it takes the addresses for that current instance when you run. There's one thing that's, but it's kind of annoying to set up GDB. I do think I have GDB there, but so maybe I should try to. I should try to get the address of Enki and then run GDB to see what happens. I have to remember which commands you use to pause in the beginning. I'm not sure if this is worth it to this. The problem is I will have to compile because Enki is gonna be too big. It's gonna have too much stuff. I'll have to compile a simple program. I don't want to know. Yeah, I don't want to do this right now. Maybe some point later. I'm gonna think about like a different way to test this. 'Cause the problem is that if I test with the maybe if I turn off the optimizations. 'Cause I think the place that I've seen addresses the most is when you're using GDB. I guess I can just ask the ChatGPT. Yeah, so I think that the main thing is the virtual to physical. So like the virtual is like a box of abstraction that allows the program to allows the program to have consistency within itself, but that doesn't mean that those addresses are going to be the ones that are used on the hardware. But on top of the virtual mapping, you're going to have other abstractions that are going to take the initial memory that the program is like using as an abstraction to the actual memory that is going to be used on the hardware. And the logic is going to be the control logic of the hardware to manipulate the data in relationship to different threads and different processes running at the same time. And different privilege rings based on the operational system. So I think it's all connected. And that's the part that's very hard to clarify. I think mostly you probably just use registers on the program, and then if you get the executable, then you're gonna have the addresses that are the virtual addresses. So like the abstraction is the addresses are in relation to the abstraction of what the program represents, which is the stuff that I was talking about earlier. Just the static, the heap, the data, and the text, I think. And there's another sections that I forgot, I think. But those like it's like a template or an archetype to the representation of a program. So it can encapsulate the abstraction on itself, let's say. Like, can decouple the abstraction from programs through the structure of the hardware. And the standard is bridged by the control logic. So the standard is the abstraction that represents the program, and the complexity is the using that standard to bridge the gap between the hardware structure and the software structure. So I think I have three, and maybe it's more. It's probably mainly two. So the two main finite state machines are probably the ones that determine the rings of the system, the privileges, and the ones that determine the cycle of instructions. Let's see. I should see if I can find a cheat sheet. So maybe I should just that kind of one's kind of hard to. I guess I can just test I can just test multiple different things and then see, just write down the registers that are used. Accumulator base. Oh, the Anki thing that I was gonna show there. They do talk about this difference, but I don't. I think I have to do something similar to this. Yeah. So I think RA and then X for like the variance of them is gonna be AX. So AX. Probably the best way is to get the most common stuff that is done all the time. So I think about like initial function calling of functions, declaring pointers, declaring structs, and stuff like that, and then trying to memorize what usually happens on these patterns, because everything else is going to be abstraction that is just going to be a combination of those things. I think the main things to one thing that is kind of, it's not really uh, confusing, but I think it's kind of hard to memorize, is the comparison between strings. But I think it's because it's going to depend on the language, obviously, and I think if the language supports, it's just going to be translating from the characters to their Unicode representation, probably, and then comparing that with whatever value you have on the other parts. But I guess I can try to. So I'm gonna ask what are the best examples. Maybe you can ask for examples and then test there. I think this is the one that was right. So I'm gonna change the stuff there on Godot. Then I'm going to change the message. I think that I solved last time. I had solved the one that isn't the static one, so the message is not gonna show there probably. Also because I changed the message, but I'm just gonna change the message, I think. So it is changing. It is showing because I changed the condition there. I'm just gonna leave it like this. Then maybe in the future I will see if I do something about it. But this one is gonna be the SPB, I think, or SP whatever. SPR. No, this is stack. I don't know. SI. It's probably B, X, something. Yeah. Yeah, on the risk V, I think I remember the A0 is the one that you use to return. So probably what I'm gonna do now is ask ChatGPT. I'm gonna ask for the list of the main registers and what do they do. The instructions are very easy. Oh, the shifting ones are annoying as well because there's different variations. So you can shift by keeping the sign of the last or most significant bit, or you can shift not keeping the sign, and the other stuff that you lose is gonna be discarded. And the mathematical operations are just annoying based on the amount of bits you have. But I think probably the best way to like solidify this stuff is by trying to get simple examples that are complex enough to be able to integrate what it means. So I wanna work up to the TCP/IP. Not 100% sure which way to go, like from the top level or from the bottom. Because the complexity is gonna be on the middle. So I'm gonna see. I'm gonna think about like steps here, and then based on the steps, I'm just gonna reset the history there on the LLM. So I'm gonna think about steps. Then based on the steps, I go over with the LLM. Each step, I clarify things, and then I test. I think. The next thing that I have to do is sure. I have to study and implement the stuff on Godot. So after I do this, I'm gonna study and implement the stuff on Godot. Because I think I'm just gonna like clarify stuff, organize stuff now, and then I'm gonna do this upstream, probably I'm gonna do some exercise now, and then probably the rest. Like I have to read all this resource here and keep watching the videos there. But I think for organizing, like just showing how to organize the stuff and think about, because the way that I'm thinking about is like you have, so like the problem is always going to be you have a range and then the complexity is on the middle. So either you go from the very complex stuff, which is obviously impractical because it's just going to involve build systems and a bunch of stuff like that. So there isn't a way to train, or you go from the very simple stuff. But if you go from the very simple and you don't have a direction of where you want to go, it's not going to be grounded into anything. Like it's not going to be grounded on the context of this information you already know in your mind. So you need to find a way, the middle way, to create the most effective steps from the place you know right now to the complexity. So this is the reason why I'm thinking about. So I'm gonna write down there. So it's not showing anything. Nice. So next thing that I'm gonna do here, I probably look into some instructions here. Because the idea that I had to, I was building here, but then I realized that it was very bad because there would be a lot more files here. So that's why I downloaded the other version. Then I'm gonna delete this one, and I'm just gonna do it from the other one. But the idea that I had with this was just to see what kind of instructions are actually being used on like a complex program instead of a simple one. And this is kind of the idea that I'm going now, that I'm thinking about now. So first, uh, find TCP, IP, C++, source, and search for based on patterns. create lists of instructions to understand. I'm not sure if it's relevant. So I'm gonna if I can find the C++, I already seen some tutorials and videos that show, but I want to see more the real thing. So just from the real stuff, I don't want to spend a bunch of time. Just want to like skim, and I'm gonna search for I think probably the data structures, and then see if I can find the frequency on the on VS Code of how much they're used. Obviously, it's gonna be the simple data structures. I have to see if I can find like maybe if I just go from the simple data structures and think about the patterns. I think typing is also very important. So like usage of static cast and dynamic cast and buffers as well. Probably buffers is the most important. Buffers and dynamic memory. So anything that involves characters and so after this puts the uh, puts each example I think that's probably just these steps here is gonna be enough to have an idea. Obviously, just the beginning, and then I'm gonna do other stuff, upstream probably. I think after that, probably the best thing to do is just to study the Anki thing there with the IDA free. Just study the code here. And for each instruction that I find here and I don't know how it works, I can just research and then clarify. And it's probably the best way to go about it. So this one shows like a real thing. And then maybe from that point create. The thing is like I don't care that much about creating simple programs because it's not gonna be maybe as an exercise just to like make sure that I remember stuff. But probably on that point, it's probably better to study the compilers and LLVM. I think it's gonna be a waste of time to create simple programs. So let me follow the. I'm gonna close. Actually, so I'm gonna close some of this, and I'm gonna go from the other way around. So I'm gonna do it on a loop, obviously. So like this stuff, as I close this loop, I go back. So as I go through this, I'm gonna be able to have more references, more reference frames on my mind of what stuff is confusing still. Then I create other keywords to explore. So this one's very good. I'm gonna leave this one here, I think. Floating points are very annoying to remember as well, but now I understand how it works. So you just create the different representations of the numbers and use the base 10, the abstraction of the base 10 to convert. And then you have the standard of what's going to be the limit from the number that is on the left of the dot and the number that is on the right. And you do the exponent based on the sign. So you have to take the offset from the sign. So it's to the power of the number that the binary represents minus the, it's like basically inverted because of the sign. But that part's kind of confusing. So the most significant bit is going to be elevated to the power of the how many things that, how many bits it has minus the negative value, I think. So for example, if you have 8 bits, a byte, you're gonna have I think it's 128 minus 127 to on the most significant bit. So it's basically inverting the order to declare. But that part is very confusing. Let me see. So there's one that seems very simple here. Let's see if I can find. Maybe I should ask. I'm gonna ask Perplexity because it's probably better. Oh, actually, now that I think about it, I should probably study the Godot thing because then I kill two birds with one stone. So Godot has some stuff, but I think Godot uses UDP, but you can use HTTP as well. So Godot provides both. But I think for your real-time games, UDP is probably better because it's more dynamic. So the way that I think about it is that TCP is more masculine, UDP is more feminine. So it means TCP is more rigid, and UDP is more flexible. But TCP is more reliable. So I think Godot has both. So we should probably study the Godot one, and then from the Godot, the biggest problem is the thing about extracting. So maybe we should just look for the patterns that they use. But I guess it's just gonna be the fundamental patterns of C++. So like classes and stuff like that. And the problem is that they are gonna include a bunch of libraries. So I'm not gonna do the TCP/IP on the compiler there. I just want to see the patterns. But maybe like I already know it's gonna be the same stuff. It's just gonna be like because it's fundamental patterns of languages. But the challenge is in converting the abstraction that is used on a practical thing to the compiler there. That's the problem. So if we're just doing some stuff like declaring a string and looping over the string and stuff like that, it's not very interesting because it doesn't allow you to create a model of how the different systems are connecting with each other through the hardware. So like how the monitor is going to connect with the network, the modem, and the like different inputs and outputs that the system has. But I guess like there isn't any other way because when you get to the level, you need to use something more complex like IDA or some other program to go over all this stuff. I guess I can try and show. Just copy and paste the one that I found there. I'm gonna use I found two here just searching on the search engine, and it seems that it's very simple. It's just a couple of files. Probably they use, so I'm just gonna try to copy and paste and see if it complains about stuff. If it does, then I do the stuff that I was talking about. I'm gonna do just the data structures and then write down the registers and stuff that is used most of the time. Then after I do that, I try to clarify how the systems are connected. So basically, the main reason to do this is to create branches of exploration of the fundamental principles of how the systems connect with each other to clarify the big picture. See what happens if we put this here. It's from. I think it's because there is no main here. There's probably not gonna show. So maybe if I create action handler. So it requires, yeah, there is no definition, so I have to define. But this is the thing that is annoying about this. If we're gonna get anything complex, we're gonna have to. I think the main thing that's kind of annoying is the build system. So it's like figuring out how to deal. I guess the only way is to use CMake and then build locally and then compile with the flags to generate the assembly. Then use that. Probably that's the only way. Or choose another debugger. Thing is, I don't wanna use Visual Studio, so I think I'm pretty sure I can use GDB on the command line, but I'm not really sure about the symbols. So let me try this other stuff. I'm gonna do what I said there before. I'm just gonna do the simple patterns first on this thing. Then I'll think about what is the best course of action after I finish the list there. So just look for the patterns here. I'm gonna try to copy the simple ones there. It's probably not gonna work, or it's not gonna show anything. Oh, it did work. Nice. But I got a segmentation fault, but doesn't matter that much. So obviously it's more interesting to see the assembly. I'm just seeing here. I think for each function that you have is going to create a label and then use the jump instruction based on that label. So the compiler automatically does that. And Clang, as far as I understand, is just a front end that uses LLVM as the backend. So the way that compilers work, at least these compilers, but probably all of them based on fundamental principles. That you're gonna have the front end, which is the synthetic analysis, which is basically creating a finite state machine. Finite state machine is just a graph that represents transitions between states. So you're gonna receive a string as an input. Then, based on the rules of the grammar you have, first you're gonna create the words of your language, which are the tokens. Then, based on the words, you're gonna create a tree, which is the meaning that the words create, which are basically the phrases of the grammar. That's the abstract syntax tree. Then, based on this abstract syntax tree, you can traverse the tree to derive the meaning of the phrases and check for errors and stuff like that. And also create the variables and the scope of the variables. Then once you have that, then you can use something like LLVM to create an intermediate representation of the language, which is just an abstraction that is going to work for translating the language into multiple different architectures. So that's the code generation part, which is the backend. So LLVM creates an abstraction, which is a language that is like language that is translatable into multiple different architectures. So as part of this process, you're gonna have a bunch of stuff that is used to optimize the code, because you want to make it easier for the programmer to write stuff, and it's gonna be the job of the compiler to know the hardware architecture and then to optimize the declaration of variables and the jump instructions and stuff like that to make it optimal for that hardware architecture. And then here, I think that they put the optimization flags by default, but I'm not really sure. Yeah, so I guess you can select different flags here. Show more stuff. I think in the beginning I'm just gonna do like this. I'm gonna look into the C++ code first. So I'm gonna do it with this one because it seems that at least it shows something there. But I'm gonna download this other stuff here. This one seems to be very easy to just run the CMake. So I think that's interesting to download this as well. I'm gonna use these ones in the beginning, so I'm gonna search for the Godot. Maybe the Godot is easier to find the entry point based on the documentation. The thing that I wanted to do here is to study the string as well. Yeah, when I studied the flow, when I studied the parsing method that they use for reading and writing to the sync files, and also translating options, I think. I want to see like how they create the. Also, GDScript already spent some time studying, but I want to see the methods that they use to parse the strings. I'm gonna close everything probably. This. I'm gonna see if it's easy to. I'm gonna use Perplexity to see if I can find like. The documentation obviously has. So I'm just gonna use Perplexity to see if I can easily find the classes that are used for the protocols on Godot. Then see if the code is relatively easy. I'm gonna do both probably. So see the one there, see the Godot one, then writes the stuff that is used. Check the patterns on the compiler. And so I'm gonna close all of this stuff. So maybe I shouldn't. Zone Cortex. I was gonna change this stuff here as well. I wanna like finish the. There's sure things that I have to finish one. So yeah, this is what I was gonna do. 'Cause at the same time that I do this stuff with assembly, I wanna finish the initial template that I'm gonna use there, which is just the pop-up menu. So I have to get from the editor. So probably search here. So it's gonna be on the editor node. I'm probably not gonna use the assembly. Maybe I'll use after I do this whole loop and this all this other stuff. But for, because I was just curious to see the assembly on the actual thing, how it works. Yeah, but I'm gonna close this stuff. So what I'm thinking about doing is just initially, so I'm just gonna create another class on the modules, and initially I'm going to uh, I'm thinking whether or not it's worth it to create a folder here. Initially, I'm just gonna copy the stuff that they have on the editor initialization to create the stuff that shows up on the corner. It's basically the file system, the stuff like to manage these options here. So I'm just gonna copy the stuff they have, then I'm gonna replace, or I'm gonna add that to the layout that I have there. Then build the scene. Then once I have that class, then just have to study the file system next, and then implement the file system on the dock, and then change the other stuff to use the viewports to create a simulation on the other side. Once I have that, then I can go back to studying this other. So I want to do these two things at the same time now. So a little bit of this and then a little bit of the other stuff. Thinking about what's name sure. I'm probably gonna start which name to use here. I'm just gonna leave it like this. Then I'll think about later. So I can be the name. The standard nav bar. I'm just gonna try to create this. So this one's gonna depend on what they use on the editor there. I'm just gonna see what they use on the editor and then I'm just gonna copy. I wanna do this first to compile. Probably I'm gonna use a container anyway. Sure. So let me see. This is a problem. If I open this one, it crashes. I might try to fix this as well. I can move to this one. Just with sync files. So this is the main thing there. The title bar. Third title bar. So it's an HBox container. Let's see. So the problem with creating this, like, I'm probably gonna do this way now, but the way that I was thinking before, and I'm not 100% sure about this yet, but like the challenge with this is that the purpose of creating this class, in the way that I'm thinking about, would be to create anything possible, and then you just change the data for the class and change the functionality. But I think it becomes a lot more annoying to think about. So probably just in the beginning, I'm going to think about creating this class just for the instance of the thing that I want to do right now. Because the problem is that the menus, the functionality of the menus are going to depend on the functionality of the scene. So it's hard to think about how to structure things without coupling them. Because if you're going to create a class to be able to use in a generic way, where you just reuse the class all the time, then you have to think about how do you make sure that the functionality is going to be external to the class. That's the problem. So it's probably because of the SC sub. So every time, oh, you have to put, so the way that I'm doing here is, like the SC sub file is going to be the file on scones that is used to include the C++ files on the module you are building. And it's based on the way that the main S construct file works. So they automatically go over all the modules and then they look for the SC sub file on the module. Then when you import AMP here, you're just using the same environment that they're using. And on the main S construct file, they're gonna declare these module sources, which is a list of C++ files that are gonna be incorporated on the module library from the main build. So here, just put the path. And you can either do like this, where you're putting the relative path from the source on the main SC sub, or for each folder you have, you just include another, you just put another SC sub on that folder, and then you just call sconscript, I think, here. And then you put the path of the SC sub, so it would be like U elements, the one that I have there, and then SC sub. And then this would make the file you put here run as a script, as a Python script that is part of the build, and then you would put the same stuff there. But because it's not a lot of codes, it's easier to just put here every time. Yeah, and then you don't need to put the S sub on the relative folder. So I think that this is the reason why it's complaining with the linker here, because it can resolve the symbol. It's not part of the build. Already included in the environment. So this is related to the other stuff that I'm building, but I'm not really sure. I think I'm including twice based on the way that I did the SC sub, but I'm not really sure. It's probably because of the. I don't remember exactly where I did the. Because I thought it was harder. I think I copied. I think I did it on the Cortex. I think. Yeah, but I do think it makes sense to put as part of the editor sources here. So I think what is happening is that when it compiles the editor, it already includes, for some reason, the files that I have there, based on that sub that I have here. Because this one is the one that was kind of hard to figure out. So this file dynamically generates the C++ file on build time that is used to create a function that is endpoint for the projects. And I'm adding the source files as with this pattern, but I thought that it was only gonna add at this level, so that's the reason why I put the other one there, I think. But maybe it's just, I'm not really sure. Because it is just a warning, so. So it's complaining about the bind methods on the other thing. So this is the thing that makes it run, I think, the file that I have there. So like this SC sub that I put here, I'm running through here. Because I don't know the name of the project that I'm gonna put there, so this is the name of the folder basically that I put. It's supposed to reflect the name of the project that I have. So it just runs the SC sub and then it adds the sources through this SC sub to the editor sources. But I'm not really sure why it's like it seems that it is warning that it's adding twice the files. So I assume that's, but this pattern shouldn't, or maybe actually when you put the star, it does for everything on the. I guess I can test to see. I can just comment this out and see what's gonna happen. So let's copy this. It's still warning. A custom property GUI, including environment sources. Custom property GUI. So this comes from the module though. Hmm. So there is a conflict between the module and this one, I think. Project layouts from cloud. What is going on? It's probably because of the includes. I think it might be because of the way that I'm including this. So it probably wasn't the thing here. So I think it might be because of the way that I'm including. It's just a warning, so I don't think it's not crucial to fix. But it is kind of weird. Because based on the error, it seems that it's complaining that this is adding, trying to add again, I think. Like these files are from the modules, I think. Yeah, it is from the module that I created there, including environment sources. So why would it try to add this? The only explanation I think is the include. So let me. Well, also I'm not using here. So maybe if I just delete. Not using serializer as well. So let me see. No. I think it's just different warnings. So it's confusing because of the sequence, but it's probably different warnings. So I think the only thing that makes sense is that oh, I'm adding twice here. I just copied wrong, I think. So this was probably a long time ago. Or maybe not. Yeah, so it's probably now that I copied twice. So this is the issue probably. Yeah, because it wasn't showing this before, so it must be now that I copied by mistake there. So now that I have this, so I'm going to focus on the assembly now again, and then later I'm going to finish this stuff. So I'm gonna copy the code from the editor there. So this stuff that creates the options here. The options, it seems that it's just using classes from the scene, so I can just do the same thing. But I have to understand the functionality because the difference is gonna be on the data, I think, probably. So I have to spend more time studying this stuff. So maybe put breakpoints as well and then go over with the debugger to see what happens when you select the options there. That's probably what I'm gonna do. I'm gonna focus on this first. I'm gonna go over the assembly there. I'm gonna create another thing to write down the patterns. Yeah, so I think this one, I'm gonna use the one that I have there. So the list, I'm gonna create examples. Uh, I asked ChatGPT before to find examples, but I think that it doesn't, like I couldn't find. I didn't spend that much time, but I couldn't find in a simple search. Did I download this? Well, download the examples so I can. We're gonna create another folder there on the stuff that I have. Maybe this is probably better to create a couple of functions so I can go back to them. So create a folder on the C++, create a push this TCP stuff there, then create C++ files with examples. It's been a long time since I didn't use CMake, but I think it's probably gonna be easier, like to just compile some files. Can look into the example that I have here against one that I already did some time ago. And that's what I'm gonna do. I'm gonna ask ChatGPT. So yeah, so gonna download the stuff, put another folder for examples, and open on VS Code. Then like look into the codes, write down the patterns, ask ChatGPT for examples. Then write the examples on the file, then copy them to the compiler. Or create, ask for the examples first, then create examples based on C++ files, put them on the compiler, analyze them, maybe maybe download the assembly as well. I guess one thing that I can do is just go from C++ to the assembly on the compiler, then get the code from the compiler and put on the emulator. I think that's probably a good idea. Because then I can try to do experiments to change the order of things. Like once I go with it enough times. Um, I already forgot how to do stuff. Now there's like put projects and then it puts add executable. I think add includes or target include directories, something like that. I'm just gonna copy from the other one that they have here. Let's do this. I guess I can add subdirectory as well to see if I can compile the other one. Then just run cmake on the command line. And this might be a problem. This is kind of annoying because sometimes you have errors here. Was target add include directory? Maybe I can find some examples from before. But building is, for now I don't care that much because I'm just gonna see on the compiler there. Or maybe in the future I wanna do it from here. Also compile with the flags, just see the difference. Yes, targets include directories. Got from another example that I had there. We're just gonna for now. And maybe to make it easier, just put the headers on the include, so I don't have to think about. It's probably the same directory, just do dots, but I'm not really sure how. As you can just remove, whatever, doesn't matter. So here, this, this. I'm gonna try to do it like this to see what happens. I think first, ask for examples. Yeah, but it's kind of the same thing. So write down the examples here on a list of like list of concepts to implement there. Then use this list to create. I'm gonna do one by one because I think it's easier to get the code from the LLM instead of pasting all at the same time. So each one I guess I just put on the example file. So here, I think it's gonna be, yeah, so I have here. So this makes it so that you compile the current directory. So S is for source and B is for where the build files are gonna be at. So it's gonna generate a build folder, I think, from the current directory, if I remember correctly. And then after you do this, depending on which compiler you use, I think you use /g if you wanna select a different generator. And the generator is just which compiler you're going to use. But if you're using Windows, by default, it's going to be MSVC, which is the Windows compiler. And I think you need to install Visual Studio because Visual Studio is going to install the compiler. But if you're using MSVC, then I think you don't remember which. But I know you have to run another command after, because the first one generates the build files, and then you have to run another command. I think just build. So cmake dash build, and then you just pass the build directory. But I probably have on the history there of the commands. Also, at this part usually you don't get an error. Only on the other parts. But I guess if like for simple things like this, probably not that hard. You're probably not gonna get an error. It's only when you're gonna use shaders and when you have more external libraries, that's when it gets annoying. It's been a long time, so it's gonna be hard to find. Let's make. Yeah, so I think it's this one. CMake builds. I'm just gonna do the builds, and I think I'm not really sure if it's. I think it's probably builds. Yeah, config debug. So it's probably this one. Valid arguments. So they probably did the other CMake for another compiler, I think. AW. We're gonna remove this from here, and then remove this one. This is probably for ceiling, I think. So I think I need to put main here and return one. And RC shards argray 0. This is the issue. So this problem I think is because of the external libraries that this probably uses. So it's not finding, maybe. So I'm just gonna do it without this stuff and just see if I can get the other ones. Maybe in the future try to solve the issues there. I was gonna look for main example. I guess Godot has. Just wanna check to see how they use two different things. But I guess it's the same thing when you use a pointer to a pointer or when you use a pointer to the array, the empty array. Differs. So there's also some interesting stuff when it comes to assembly of about the arguments. So usually you're gonna have a pattern for putting the arguments and you're gonna have a maximum amount of things there that work by default, and if you go beyond this amount, then I think there's something different that happens. So obviously that's one of the things that I should put there as examples to see the location of the arguments and the alignment. Yeah, so it is the same. But uh, so I'm gonna leave it like this. See, works. So I think it didn't work. Hmm. Oh, sure. So it did work. So obviously it's not gonna do anything to run. Yeah, but I think it is working. So I'm not gonna incorporate the other file, the other project. I'm just gonna focus on the examples here. I'm not really sure if I'm gonna just doing this to get the initial like thing. Then probably I'm gonna use IDA to explore different stuff. So yeah, let me do what I was gonna do now is just read this and then find the patterns here. I probably already know the patterns to explore. So I'm gonna write down here. The thing is, it would be nice to go so like declaration of simple variables. Buffers. So buffers are very complicated. Like there's so mainly overflows, underflows, stuff like that. So here, but the problem is I'm not really sure if it's gonna compile. So I can ask the LLM to see if it produces one that could be compiled, that maybe is not. Yeah, I don't know. You can just do variations and then see. So I'm gonna take a break and then I'll continue this. So I'm gonna take like a 20 minutes, half an hour break. And when I come back, I'm just gonna continue. So I'm going to follow these steps here. Probably I'm just gonna do the examples now, because I already know. Um, it's not. I think that this is not the most accurate because realistically, you would probably have parsing, and I don't see like parsing here. But obviously, I didn't spend too much time to understand this. But I think this is a very oversimplified version of the thing. It doesn't matter that much because I just wanted to see or to remember. Probably these examples here that I have are gonna be. I'm gonna ask first for examples as well. So to get the examples from the LLM and use mine as well. Then once I have the list, I just ask for each example. I'm gonna ask for a function. I'm gonna put the function here on this and here. Also pointers, pointer types. So the goal is to go from like simplicity first and then get more complex and try to capture all the patterns and then see capture all the patterns on when it comes to the assembly, what registers are being used all the time and stuff like that. And then after that, I can think about the fundamental principles, then expand. But probably after this, I'm going to study offline, off stream, but I might continue on stream before I continue to study this on the other stuff that I have to do, which is just translate the editor node stuff to the class that I have there on Godot, and to finish building the first thing that I have there. So like once I get to this point of clarifying the fundamental things, either I could do like I said, compile this with the flags for assembly and then see the code they generate on assembly here, and then put the code here, and then try to rewrite or write more complex stuff from assembly once I understand fundamental patterns. That's probably what I'm going to do first. Then after doing that, I think probably not gonna do this one. Because from that point, the main thing that I'm focused on is clarifying the complexity of the hardware architecture of the different components. So the goal is to create or expand the keyword graph that is the entry point to expand the fundamental principles. Yeah, so after this point, I have to think about like path of exploration to clarify the fundamental principles. So I'll be right back. Okay, so back. So now ask ChatGPT. So arithmetic operations, variable declarations, assignments, additional statements. Yeah, I think that's function overloading. Object-oriented is the hardest one because it's inherently complex, I think, to... So for example, let's say you have a class, an abstract-based class, and you want to have templated classes that you're gonna do stuff. It becomes very complex. Even the simplest example, if you want to test object slicing, for example. I don't remember. Let me search again for... Because object slicing happens, I think it happens only when you're trying to copy the data. So if you have a... And there's a problem that I learned recently, which is the translation of types. Let's say I have a base type, and then you declare a class on a derived type from that. And on runtime, you wanna cast that to another derived type. Let's say class A is the base, and then you have B and C, which are derived. Then you transfer on runtime from because you have to define the type as A, which is the base. You initialize a class with the B type, and then you transfer that to the C type. That makes sense. Through the base, which is the A. Whenever that happens, you can have problems. So it's very dangerous. But this kinds of things is very hard to see there, I think, with simple examples. Also, the other thing I was thinking about is that I should probably, like, after I do this stuff in the beginning, instead of using the emulator, I should just use an assembler. The one that I know is NASM, I think. And see, depending on how hard it's gonna be, just see how to compile on VS Code, and then I could just write the assembly on VS Code. That's probably better for more complex things. So object slicing. Yeah, this stuff. So when you pass by pointer, I think you don't, it doesn't matter because you're just passing the... So the pointer is just pointer is a value, but it's a value of an address. So because what the pointer doesn't, unless you're doing, maybe when you're doing transferring pointers, but I think if you're trying to reassign pointers with different types, then you're gonna have a problem. Like, it's not gonna allow you to compile. So you're gonna have to use static cast or something like that. And then I think static cast is dangerous, but if you use dynamic cast, it solves. So probably not gonna for this kind of stuff. I think I'm gonna have to think more about it later. So inline assembly, I forgot some templates. And this I'm gonna put here. So what I'm gonna do there is just like put copy the function and then remove one by one and then see. So probably, hmm, I think about this. Because what I wanna do is write down the patterns. Uh, Should probably do a hacks thing here. And also didn't do. This is the one that I was looking for. So yeah, I'm gonna ask for like calculations. So what I'm gonna do is just these main functions, and then on the compiler just copy the whole thing, and then I remove one thing at a time. I think that's easier than do a bunch of smaller functions. Define or declare this. I guess define as well here. And the problem is gonna be, yeah, but I guess I can just put there. Whatever. It's kind of more annoying on the thing because I'm gonna have to put it there, but doesn't matter that much. Mm. Probably lambda. So I remember a video from Jason Turner that he talks about that he. Well, actually, I might have here as well. So it's been a long time. I don't remember. Like, I'm pretty sure I wrote, but I don't remember exactly where I put this. But there is a video where he goes over all the concepts on C++ that you need to know everything basically. And he says on the video that like the vast majority of those things you can do with Lambda, and I'm pretty sure that that's how he recommends to do stuff on the compiler there to see. So for that reason, I think I might do a whole nother file just for lambdas. And I think it's going to be more complicated, so I think it's better to do this later. So after the initial steps here. I don't remember really well where did I write this stuff. I'm gonna remove a lot of these things here. Oh, I found this. This is basically the list. Let me show the. So this is basically the channel, and I got the list from this. It's one of the videos here. I don't remember which one it is. I think it's probably this one. Yeah, it is this one, I think. I'm pretty sure. So in this video, he talks about all the concepts you need to know. Not that you need to know that are like all the C++ concepts. I think he does lambda. So maybe yeah, maybe I should do this. I think I'm gonna do this later. I'm gonna watch this video again. I'm just gonna see there's examples he does this, but like it's easier to get from ChatGPT obviously than to copy paste. I think copy pasting from what he does here. Maybe he does have a maybe he shares here. So if he shares the code, then I think it's probably easier to get it from here. 'Cause I did search, but when I searched for examples to use there, I forgot about this video. So maybe we can just get the examples that he has here. Yeah. But I think I'm gonna do this stuff that I'm doing. So I'm gonna do the simple examples in the way that I'm doing there now, because I think that from what I remember is more complex. The examples he shows it's gonna be more confusing in the beginning. But I'm gonna do the stuff that I'm doing now, and then after I finish with this, I'm probably gonna go back to this thing here. I'm not sure if he, but I'm gonna watch the videos again. Not sure if he wrote the examples there. I'm gonna ask one for so I'm gonna continue these simple examples here. Then after I have the simple examples, I'm gonna search to see if he wrote the codes somewhere. If he didn't, I might spend the time just manually going over the video and just copying everything into a file. I'm gonna do a separate file on the project here. Uh, For the arguments, I'm gonna have to watch some other videos because it's a problem. I'm not really sure how it works there when it compiles. but I guess we'll see. I'm gonna skip this one as well. This ones I'm gonna skip. I'm probably gonna do later, or just like search for videos before. So I think for the more complex stuff, I'm probably gonna figure out how to use the assembler or just put the flags to create assembly. Now, putting the flags to create assembly is probably easier, and then just find the examples on C++ or create simple examples using ChatGPT. Then just compile on VS Code instead of using the compiler of here. Then go file by file and see how it works. The last one that I'm gonna do is this one. It's probably not worth it to do now. I'm gonna leave it like this, so I'm just gonna put there one by one. So let me see this one first. So obviously I think it's gonna start from the main here. So this one is the one that I got from TCP IP. So I think it's pushing the register base pointer. Then it moves this value again there. This was exactly the same as the other one. So there's this thing that called stack frame, obviously. So I think every time that you call a function, there are going to be patterns that are repeated, and it's going to depend on whether or not the function has arguments. But either if the function has arguments or not, you're going to move the pointer and move and remove the pointer. So push the pointer to the stack in the beginning and then remove. And then I think depending on what the structure of the function is, we're going to allocate memory in the beginning. And there is uninitialized variables as well, but I don't remember really all. So I'm not really sure why it's subtracting here. So I'm just gonna skim over this, but I'm not gonna try to understand because I'm gonna focus on the simplest examples first. So here, I think it might have something to do with the arguments there. The function call here. I think based on the types of the arguments is gonna move to this, I think. So he's doing the other way around, I think. So these are the arguments there. So the first one is 0. I think it's because of the function call here. So before it calls the functions, it moves the values into this pointer register probably. And then after it does that, probably moves the pointer. So each instruction is gonna automatically, I think the default is gonna be a -4 or yeah, I think -4 because it grows down the stack. So every instruction is gonna move the pointer by 4 automatically, I think. But I'm not. So probably the compiler does this automatically. But I think if you're writing the assembly yourself, you have to do it. You have to write. So it moves. I assume what is happening is that it's moving to the register and then moving the pointer to the next instruction. And then the same here. And this move is based on the size of the thing. This AF nuts is bigger than the other ones. And it's highlighting there. So assume that this is gonna be the function call there. The yellow is the function call. So move through to the register. It's probably from the library, so I can't see. XOR, as far as I remember, when you do the XOR with the same register, just zeroing the register. When it XOR the register with itself, you're just zeroing it. Yeah, because XOR is gonna be 0 whenever they are both the same, whenever they're both zeros or both ones. So because they're doing it with the same value, it's gonna be 0. Here, I think the call is probably calling the label. It is the function. So Leah, I forgot what it is as well. So compare is probably the branch. It's comparing 0 with whatever it has here, which is probably the stuff that was here. Which is the result of the call. I moves. No, I think move is the store and loads on the risk v. You read the other way around, but I don't remember on the x86. So I'm just gonna erase this one for now. I'm gonna put the first example that I have there. So let me remove everything first. I'm just gonna do one by one. So again, it's moving. So now I'm gonna ask there, GPT. So this one I'm gonna. This happens a lot. I'm gonna write here. I'm gonna write the patterns that I see most of the time, and then I'm going to ask ChatGPT. And then later, obviously, I'm gonna watch a bunch of videos and then probably read other resources and stuff like that to clarify. So, registers. The first one's gonna be this, which I think is this one. Then you have this, yeah, register base. So what is happening is probably also, yeah, that makes more sense. I thought that it was weird that this was the first instruction because not pushing anything through the stack. So I think this is the first thing that it always does for function calls. It just pushes the base pointer to the stack, and then it moves this other to the stack pointer register to the base pointer. Yeah, so as far as I remember, function calls are linked list. So every time you do a function, you're just doing a jump in link instruction, and you're saving the address of the other function on a register. Then based on that, you can go back and forth into the stack, and that's what the debugger uses as well to provide the symbols for stepping over. Yeah, so what is happening is just pushing this base pointer and then pushes the value of the stack pointer to the base pointer. So the base pointer is probably the first one, and then probably updates this other register with the current function call, I think. And then creates a linked list based on this. The other ones are probably just doing the assignments of the variable. So first initialize the pointer to the double word. So I guess based on the type, it's gonna change the maybe because it yeah. And then it assigns the value of 10 there to the thing, and it moves the base pointer because of the instruction, and then it zeroes the register. So another question is why does it zero the register there? Not sure if this is the correct way to say this. Then after it does that, it just pops the base pointer and returns. So let's change obviously if I change the value, it's gonna be 20 there. Yeah, so 20, let's put some signs. It's still the same. Copy again. It's also interesting that it doesn't put the comments there. And now it creates this other thing here. So now it's using this move as yeah, so it's doing this thing here, which is the label here. So floats are obviously like different because it requires more information to encapsulate the float than the integer. So I guess this is like an address. The label represents an address in memory, but I'm not really sure why. This has to be a register, I think. I'll put here. And then it zeroes the register again and pops. Let's see, 300. So this is the thing that is kind of annoying because I'm not really sure how people usually do this. Sure. Because obviously to translate from hex to decimal, you can, each value on the hex is going to be 4 bits. So you can just put the bits and then you can do the conversion with the power of 2. But it's very annoying to do it. So obviously you can use a calculator, but I wonder if there is a easy way that people usually do this. Let's do another value to see. Obviously, so the value on here is going to reflect the value there. And then is doing this just to move based on the same size that the thing has. Thing is, I know that it depends. So CIMD is single instruction multiple data. So it's an optimization on the compiler. On the compiler, no, on the hardware. It's when you use one instruction to change multiple places, multiple data at the same time. Also, is getting because when you use brackets, so as on the other instructions, is getting the value on the memory. So whatever you put in between the brackets is gonna be the address. So it's dereferencing the address and getting the value. Yeah. So here is doing the base. I think it's probably the base pointer at the beginning. I think it doesn't specify this anywhere. Current instruction pointer. So I guess the current instruction pointer plus whatever address it puts the float. So it's responsibility of the compiler to do. So I guess if you're writing directly on assembly, you probably have to do the calculation yourself, or you do extra steps probably. But probably you have to do the calculation yourself, or maybe the assembler is gonna do it for you. Like it's very annoying. So I imagine there is a way to do it. It's like imagine if you're writing a bunch of code in assembly, like you wouldn't want to do everything. I know that's the point of having like higher level languages, but I think that even in assembly, people probably had a way to write these numbers. So, so I have to specify the equivalent. Wonder if I can do this there. I guess I can test this here. Maybe I have to put the should not send this section. Let's try this. Also, it looks like it works. It's doing a compare and then add there. So I think that probably means that if this is possible, probably means that there is a data path to convert from decimal to assembly based on whatever you put there. I know that based on the instruction set architecture, you're gonna have the pattern because I've seen people explain this. So we have the mantissa, which I think mantissa is the one on the right of the dots, I think. So it would be 14 here, and the exponents would be the 3. I think the exponent is gonna be the value used to multiply by 10. So 10 elevated by the exponent, and that's gonna translate the thing. And then you have the sign. So you have the sign, you have two numbers that represents the value. I think the exponent is how much you should multiply by 10, basically. And the other value is the value that represents the float. So how much you should multiply by 10 is obviously gonna be where you put the dots. And the norm is gonna be the one that decides what's gonna be the significance of the number on the left. So like how many can be like 1 or it could be other number. But I think that there's probably like some data path on the hardware that is gonna translate if you do this stuff here on assembly. Pretty sure this is the case. But it is kind of weird because it doesn't make a lot of sense. There needs to be a conversion on the hardware if we're gonna declare it here, because this is obviously not hex, so we're not binary. I think even if you use hex, it's gonna convert. It has to, obviously, because it's gonna be binary. That's so we're just gonna do the other examples to see. It should probably go faster as well, to because the main point is just to see the patterns first. And I should probably just comments instead of deleting, because the comments are not gonna show there. So set true first. It's basically the same thing, it just changes the type. So double uses keywords and float uses the word. I'm pretty sure keyword is gonna be 64 and the word's gonna be 32. So this is the top of the stack. So it's basically two pointers capturing the size. That's why you always declare the base pointer in the beginning and then you move the stack pointer, which is where it's currently at. I think it said something about this. Yeah. So based on the book, I was reading what happens. You can use multiplication to check for overflows, but you can't use addition or subtraction if you start the results first. So if you do C equals B plus A, for example, and then you try to do A equals C minus B to check, it's gonna fail because if the result overflows, the math is gonna be wrong because it goes on a loop. So I'm gonna show if I can find, I'm gonna show the diagram or the chart that they share there. It's a three-dimensional thing. So when you overflow, it goes to the highest value, positive value. One like the first time that it overflows beyond the highest possible value is going to go back to the negative values, I think. So for that reason, you can't calculate using plus, but with multiplication you can, because when you divide, it's not gonna even, like, if you divide, even if you get, even if you got the incorrect value before, it's still gonna give the wrong thing. So, and if you didn't overflow, it is always gonna be the same if you divide. That makes sense. But I'm curious to, because that's another confusing thing, is like, how do you think about the values? Because that's something you take for granted when you're using higher level languages, because you just do the calculation and you expect it to work. Yeah, but I guess not, because you're gonna have a lot of situations where you're gonna have exploits based on the way that the programmer declared the types. So if you, obviously if you declare the wrong type, it's not gonna work. But I think it is different because you probably have extra steps if you're doing from the assembly. It's probably better to open the PDF version of this. So it's basically here. So this is the diagram, and he shows other. And this part, I'm probably gonna read this again because it's kind of confusing. But the way you calculate the overflow is by getting the module, because obviously the overflow is gonna be the remainder, I think. So you can calculate how much is gonna overflow by getting the module of one number to with the other. I think it's not just the module, it's 2 to the power of n, then times the module, because obviously how much it overflows is gonna like be in binary. So yeah, so this is the thing that they show here. It's unsigned addition, and this is the overflow. Then you have underflow as well on the next ones. So I guess the thing to, but I'm not really, I'm probably gonna read this again and then I'll think about this later. Like, what is the best way to deal with calculations that overflow? Obviously, you're gonna divide into multiple different steps. And here he's talking about the mantissa stuff. It's also very confusing. Yeah, so this is the part that I remember of the exponents, the fraction. I think that because of the normalization and because you want to represent both negative and positive value, you need to subtract the most significant, like the exponent parts, but I don't remember very well, so I probably have to review again. That's what he's talking about here. Bias for. So this is the formula to convert in case the number of bits you have. So if you have 8, it's gonna be 7 to the power of 7 minus 1. And then you subtract that by the actual unsigned value. And if I remember looking into your comments that they say that in JavaScript, I think on a browser, they use this part here when you have the none to store doubles. But I didn't spend time to verify this, but I think it's probably true. So let me move on to the next. So same thing on the other ones. I'm gonna ask this now. Why does it zeros the register there? Might be the return register. Come later. So like the response is not very good there. Because the thing that is weird is obviously there isn't anything here that is directly correlated. So I assume it's because of some optimization or something. I'm gonna write down so I check later. I already wrote here. To change the value here. So it's always gonna initialize the first one. because just a pointer to the first character. So moves, binds, pointer. I guess it always does this stuff here, because moving the. I'm just gonna continue, then I'll ask this later. But it's weird that it's using the base pointer there, not the stack pointer. Yeah, like I'm pretty sure that this stuff here is for moving the instruction each time there is something going on, and then it subtracts the whatever the size of the thing is. Yeah, so one. At the end, I'm gonna leave all of them, and then I'm gonna go over. But it's basically the same thing always. The only thing that changes is this one allocates the value and then moves the base pointer using this. Like this has to be a register as well. So I think I already wrote. Oh. Oh, so he's using the. I'm gonna ask why he uses the base pointer, not the stack pointer. But I think I understand what is going on. So it's just putting the stuff on the stack, putting the value on the stack, on the stack for the variable. So the thing that is kind of, I think he's using immediate because, so I'm gonna test what happens if you use the variable. So let's do here. The thing, like, how does it know? Hmm. Let me return the value. I guess you're just gonna. Oh no, now he's using. So I think the EAX is usually the register used for returning, and that's the reason why it XORs there in the end because returning 0 as the value. Yeah, so that's probably the reason why it uses the EAX or IAX. No, EAX. So the thing that is kind of, I think that I'm gonna ask what's BTR, but it's probably a register. Yeah, I guess it's gonna become more clear when I have another function there call. I think on the other function call, so the base pointer is probably the one that is used to create the link between the frames. But then what is the point of this stack pointer? So it's using the base pointer as a reference, and then it's just specifying the type, and then passing the value there. So let me see if I have true values. What happens? But I think it's gonna be the same stuff. I think it's only gonna use something different if I have a global variable. Not sure if this is gonna work. Yeah, so it creates a label when you have a variable, global variable. And then it uses this RIP. I think I already asked what's an instruction pointer. So it's specifying the type and getting the value from the type and moving that to the register that is going to be used to return. So I think on the x86 assembly, they usually use the EAX to return. And if you have local variables, it's going to use the base pointer, base stack pointer, base stack register as a reference for the values. So it's just going to offset based on the size and the order that it declares the variables. So if I have anything that is used that is outside of the function, it uses this address that is a label. So I'm just gonna put all of them and see, 'cause I think I got the point now. So I'm gonna move on to the next example. Let's do everything. So the beginning is gonna push the same stuff. I'm gonna ask what is the point of the Yeah, so it's always the same stuff. It's gonna on the bigger values, it's gonna use this instruction, that single instruction multiple data, and then it's gonna create a label, and then it's gonna put the variable on that label based on the standard that converts the type there. So this is float and double. So it only happens when with the values that have the dots, because you need to convert using the standard, and the other ones are just moving the pointer. So the first instruction is going to be the type of the value that you have there, and on the right you have the actual value you're moving. So I guess this is different because it's a very big value. So it first pushes the absolutes because it's unsigned to this register, the accumulator register, and then it pushes I think it pushes the value of the register, but it's kind of weird because it's not using brackets. So maybe it's just putting the address of the register into the other place, which is the pointer base that is based on the base pointer. This is interesting as well. So XORPS, I'm not really sure what it is. I think I've seen this before, but I don't remember what it is. So this 128 bits. And because of very big values, using this bigger register and then zeroing packets, single precision floating points. And then it moves this through the based on the pointer as well. So I guess when you move the register, you only move by 4, the base pointer. It's just the size of the next instruction, I think. Yeah, because you're pushing the address probably of the register on the stack. So if you want to access the value, you use the brackets later, I think. And this is interesting. Yeah, so it accesses the value from the base pointer there, so it's getting from the same value that it puts here. So because you have this address, like on this address which is relative to the base pointer, you're gonna get the value. So it's just getting the value moving to the EAX register. And then it gets the other value, which is the other value of the register, and adds to the accumulator. Then it does what? And from the accumulator, it moves to the value again. I don't understand why it's using EAX. That's probably because it's return value. Hmm. But here it's saving the value based on the base pointer. So I guess it does the other way around. So the first value that it gets is the one on the right. It's not really the other way around, but because it does make sense to get the unsigned into var value first. I don't understand this other true here because it's not using the other value. So this one is adding the value with itself. Yeah, because this is the plus, that makes sense. But why it doesn't use the other one? I guess it's because it moved the pointer, so uh, I'm not really sure if that's what's going on. Because it should be the same actually. Like it's not changing the value of the pointer. It's just like this value here should be the same that it sets here. So it should be this value. And after it changed by the add instruction. So this should have the value added with itself, and then it's moving to the same place. So I guess it's on this. But this is the other one already. The question is why does this one adds the unsigned var to the other? So I'm gonna remove the other. So this is the last thing I'm gonna do on this example. I'm just gonna ask ChatGPT what is going on here. Mm. Yeah, but here it is using again here. Oh, so this one is the one that adds the other value with the long value. So there's something going on under the hood that makes it the EAX interact with this other register. It's probably the RAX accumulates the values used on A registers. But I guess it doesn't matter that this one is used here as well. Oh, I forgot about this. Hmm. So EAX is already on the RAX. But it is kind of confusing, so I have to clarify this. So I think that it is loading the values on based on the base pointer first, and then because the EAX is part of the other one, it doesn't have to explicitly say anything about the other one because when it adds the other value to the accumulator, because the other one is already part of the other register, so because the AAX is part of the RAX, when you add the other value, it's already gonna have the AAX inside, which is the first value, so it doesn't explicitly say anything about it. That makes a lot of sense. These parts are the ones that are very confusing though. So I'm just gonna move on to the next example, because I think I understand now what is happening. So this is kind of boring, because it's basically the same thing. These ones are new though. This CDQ. I think I'm gonna continue this later. I'm already tired, and this like now. So I probably, if I review the instructions again, I think it's gonna become more and more clear. So I just have to memorize the main registers and the instructions there that are used most often. But I'm gonna continue to do this another time. So I'm gonna finish the examples. I'm gonna probably watch the videos first, then finish these examples later, and search for this stuff here, these questions. So now I'm just gonna finish copying the stuff from the editor. After a stream, I'm gonna watch more videos about assembly, and then I'm gonna finish the examples there. And after I finish the examples, I'm gonna think about what to do. which path to go with, but I'm not that. The main point of having of seeing the examples is to memorize the things, like the difference, the nuances on registers and the like the fundamentals to get down the fundamentals very well. But I want to focus more on the connection, like on the bigger picture of everything. So first, like do the example to clarify. So I need to take a break because I'm already tired. Then after that, some other time, I'm going to finish the examples. But then after I do this, it's gonna be more. I'm gonna have to think about a way to. But I'm probably gonna focus more on the on finishing the stuff on Godot first. And once I finish the stuff on Godot, I'm gonna come back to the assembly. So I'm just gonna close everything. So this is gonna be the main thing. I'm going to copy paste this stuff on the constructor of the other class. Let me think about it first. So probably here. Because the other stuff's not gonna be directly related to this. This is the thing that I was talking about that is kind of difficult to think because like for a design, the class should be like a template that I can use anywhere, then I wouldn't be doing this. Maybe I would have like default ones here, but it's probably gonna be like would have to be based on functions and then the arguments of the functions. So in code, which menus you're gonna put and then the functionality. So I guess one thing that I want to understand more is I'm gonna step over with the debugger. So because I want to see what happens like because they're using the base class from the scene and nothing related specifically to the editor. I think that this is gonna he's gonna use other class, probably the editor file dialog or something like that, to or the file dialog class to open the box that tells you to select the file. And then somewhere at some point it's gonna have a connection between these classes and the functionality on the editor. So when I find what that point is, because that's where it's gonna be different from the stuff that I'm doing. So just copy the stuff that is the same, then find the breakpoints of when it's going to be different, and then from that point I can change the class that I have there. Once I have this class, then I'm gonna just incorporate that onto the functions that I have there. So yeah, I'm gonna probably focus. So I'm gonna do the other stuff on the assembly now, off stream. Then I'm gonna probably next time the stream I'm going to focus more on the on finishing this other parts so the on the editor. And once I do that, I go back to the assembly stuff. Because I'm gonna merge the true. So I'm gonna open the debugger from here. So based on I'm gonna open the game from, or yeah, the project from here, then search for the tooltips or stuff like that, and then find the breakpoints here and go over the breakpoints. I probably can step into here as well. Actually, it's not gonna work because I just put there, so I have to put a comment here. Um, Sing menu bar. It's just that thing. Alright. Just gonna this. So let me see. It's probably, so it has to be the functionality on these classes here that are gonna create the events, because there is nothing here that is setting anything, just setting child and setting the tooltip. So the functionality has to be inside of the classes, and it has to be based on signals, I think. Connect ID press. So it's probably gonna be on the menu. So I think each menu, like you put, is gonna have an ID, and then based on the ID, you select what is gonna happen. But it's easier to search for the patterns on the GUI, and then just put breakpoints based on it. But it's probably gonna be this function here that runs, and this function is from the editor, so that's the bridge between the two. And then they have the functionality here, so it's not gonna be hard actually. The hardest part is not creating the class, it's thinking about how to create a class in a generic way. So if I want to do it so that it works on any case, I have to initialize everything outside of the class. So maybe put standard things. I'm gonna put the break. I already have the breakpoints here. So what I think is gonna happen is when you select an option there, because this is the callback function that is connected on the signal, is gonna run this function based on the option here. Is gonna determine which thing. What it's gonna determine based on the index of that is the item on the pop-up menu. What is the value here, and then based on the switch statement, it's gonna determine which function is gonna run after that. So when you click new sync, for example, on the sync thing there, it's gonna run this function here. And that's what is gonna happen. So I can basically do the same thing on the other class, just copy the function, but then just change the functionality so that it runs whatever I want based on the whatever thing I'm gonna build. So I'm just gonna press F5 much times till I get to the application, then see if I select things there, if it's gonna, because I probably already have the breakpoints. I'm just gonna comment this. So I'm gonna do like I said. So maybe I should change the name. I think I'm gonna change the name of the. Yeah, that's probably a better idea. So I don't have to start with the generic one. I can change the name of the class and then just create one for this specific situation. Then after I do that, then I think about whether or not it's worth it to create a standard one. So that's what I'm gonna do. So I'm gonna do like IDE navbar, probably the name of the class. I'm gonna remove this breakpoints. I'll be right back. think this wasn't showing before. Using present mode. So maybe I changed something. Or we're using present mode. Whatever. So this is a function of the pop-up menu. And so it's already. So I didn't have the breakpoints on the function. I think that triggered this. Or maybe this is the first function that runs. Because. So, but probably I didn't have the function, the signal that puts this, I think. So this is the function that I was talking about, I think. And then it sends here. Option 0. It's probably gonna be this one. Oh, this one is used on the other one. So menu option. Yeah, so here. So I guess when it emits the signal, like you don't need to bind here, because it's gonna be based on the order of the index. But I did press, as far as I remember, it didn't. But I guess it might be different on the file menu. So it's different, yeah. So on the button we have pressed, and pressed doesn't send anything. So I assume that ID press is gonna meet with whatever. You can just write down. So this is where it was before. These items are the ones that it puts there. I think it's gonna be add item. So this is probably the function that puts there on the index. So it creates the item, then pushes to this one. And the oh, so yeah. So this is the last index. So if you don't pass the ID, it's just the last one. Yeah, so I guess it's very easy to do this. So I think the way that they did it, they put the order of the enum there to reflect the order that you add the stuff. So I'm gonna look into the other examples. Trying to understand how they thought about the sequence here, because I think that it has to be connected. So the order in which you declare stuff, but I'm not sure if I like that much. Like what I'm thinking about is that I think it's fine, but it's kind of I don't like it that much because every time if you want to change the one of the submenus, then you're gonna have to change both places. So I think it increases the chances you're gonna make a mistake. So the way that I'm thinking about it is that the order in which they declare the enum there is gonna be has to reflect the same order that you add the menu options. So this is the first one that they add. Whatever. Oh, so I think you do the mapping based on this, not the index. Yeah, so that makes more sense, I think. Because you can either use the size that the thing is at the moment, or you can use or you can just pass the ID. So if you pass the ID, you just use an enum. Also, this macro initializes the thing. So I guess the way you do it, you just declare the enum inside, then you just add with this. Then callback function is gonna be, and then you connect the signal for ID process. So use, so this is a different one. think that's probably all you have to do. Switch statements. So I'm gonna obviously I'm just gonna put one option first because I have to. I guess I'm gonna go over the flow there on the new file to see how it works because they probably use another class. I think they always use the same class, which is the file dialog. To open the pop-up that displays the file selector, which is probably the one that I'm gonna use as well. That sounds fine. So I'm gonna continue. I think I did everything that I should do here. So the next thing to do is just instead of using the new scene, I'm gonna see. I'm gonna try to. Uh, but for the next step, I have to study the other class, which is the file system doc. I have to see. I think the first functionality that I'm thinking about is just like selecting the, as if I selected a new file here. So it should change the states of the file system doc to reflect. I have to see what you think about like the difference. I think when you select new file or open file, you should just change the state of this. And if you select open folder, you should change the states. Let's see. Hmm. So it just opens the application again. I'm thinking about a different way though. Let's see what happens when I select the file. Yeah, so this one, it opens the file but it doesn't change anything here. So let me, I need to clarify how do they customize the, but I think I already understand kind of. So I think what happens is that after it goes through the stuff in the beginning there is gonna open the file dialog. And then when you select a file and then you confirm, you press OK, they have another class that's connected to the signal that's gonna be emitted at the end of that. And then on that one, they have another function that runs. It's about finding the function, but so new thing. Maybe if I look for an easier, I have to see if there's another one that doesn't have a lot of functionality. So obviously I want to remove everything, just want to see how, because at some point here inside of this function, they're calling the other one that opens the file dialog, I think. So I have to find what stuff it is and then initialize that class as well on the other one and then just call the function as well. And then on the other class, I have to connect the other function to the signal of that class. And that function is going to be the one that determines what happens after you confirm the file. So here is already the event stuff. And that's weird. I guess it's because that one it doesn't open a file. And so I have to select another one. So I think open sync. So it's they do the functionality here and it's on the file. That file. Oh, this is the pop-up menu probably because of the no editor file that one. So this one inherits from the scene. So it's probably the one that I'm gonna use, but I'm gonna have to change this stuff. So I'm definitely gonna use this one, but I have to understand how this one works. The editor file dialog. Yeah, but probably I'm gonna do. I think I'm gonna have to do like another class and then just initialize from the confirmation dialog because I'm probably not gonna need like because there's a lot of stuff here. I think that most of these things are gonna be related to editor functionality and the way that they handle whatever happens after you click on the thing is probably gonna be on this class. So when you click on confirm there. The question is whether or not to like copy this class and then I don't understand why, but I know that they don't register I think on class DB the classes that they use. I think the reason why is to separate the build system, but you don't have access to the editor classes on the editor. So what I can do is just copy everything and change the name and try to register and see if that works. But then there's probably like a lot of functionality that I'm not gonna use. Or the other way is to just create a new class, just inherit from confirmation dialog, and then just see if the parts on this one that I think are gonna be useful to the stuff that I'm trying to build on the other one, and then copy those parts. So I think this function here is whatever happens after, because I remember seeing this before. So whatever happens after you click on confirm, I think, on the dialog, that the pop-up window that shows up is gonna run this logic here, and they're using the dir access. So they're basically updating the stuff that the editor uses, and then they emit the signal. The file select the signal, I think, and then based on that signal, in some situations they have other functionality that runs. So I was gonna see. The problem is there's a bunch of this. Maybe if I do equal, mem, yeah. So it's gonna initialize here. Initialize after it initializes all the menus and stuff. So I'm just gonna copy this. That's current directory. I'm gonna test to see if I can compile with this first, but probably not. Editor GUI, editor file. So, and then I'm gonna copy the stuff that I use here. I think that's all that they do here. This no file connects file selected. Yeah, so this is the function that is gonna run probably. Yeah, so the confirmation dialog is gonna emit this signal here, after you click on the confirm on the window, and then it runs this stuff. So this is the function that is gonna run, I think, after you confirm the option. But they might do but yeah, it would make sense to do the functionality before. But obviously for the case that I have there is gonna be different. So only the setup in the beginning is the same, and then the functionality is different. Also, they reuse the same value there, so they assign this value on the other function. So whatever happens, whatever enum was selected there in the beginning is going to be the same as this one. So this situation is going to be file opens. So it's going to load, it's going to run this function here with the file. Yeah, so I guess the event's going to send, the signal is going to meet with this string that has the file path probably. And then runs this, and this is the functionality that is gonna open the file. Pretty sure I stepped into this or stepped over this before because I have the breakpoint there. And I vaguely remember this stuff here. Yeah, but this is gonna be kind of annoying. So this is the problem. As always, I think the problem is gonna be on the connection. The question is gonna be how, in order to, I guess I can just do it from outside. The question is how to bridge, how to connect the outside environment, let's say, with the functionality of the class. Because obviously, for my case, there, what I want to do after you confirm is gonna be to change the other components of the scene. But because the way that I'm creating the class there, I'm not gonna have access to them. So I need to either create member variables on the class or just connect. I think probably the best way is connect outside of the class. So like I initialize a variable, initialize a file, and then instead of connecting here, I expose the file and create a getter for the file, and then outside of the class I connect the function that is gonna run after it's, because the function has to depend on the application. Then based on the other function, I change the. Yeah, but it's kind of annoying as well. Like this is the biggest problem with trying to do, like with doing what I'm trying to do, because of the way that they design the system, everything. So like it kind of forces you to put everything inside of a class, which is not very good, I think. It's like the composition aspect comes from the signal. So like it's very hard to design things in a way that they work for a bunch of different cases, because you get into this problem of the relationship between different components. So the issue is like if I do in the way that I was talking about before, then I have to put the logic of the function that is gonna run on some other class, which doesn't make a lot of sense. Like it makes the most sense to make the callback function as part of this and then connect here in the same way that they did. So I'll change the editor node to this class. I guess I can always search for the node based on a name. And so usually this is the way that I been doing, I think. So whenever it wants access to the whole thing, either I can use the global signals class or I can just search based on the roots, the scene roots for the nodes that's gonna be coupled with this. So let me think. I think it's probably better to use global signals this time because the point of this is should be work like a singleton. So whenever it changes, whenever I click an option, it should send a signal to. So probably what I'm gonna do on this is just like on the callback function that runs after it's selected, I just emit a global signal with the string that is the file, and then any component that wants to implement connects to the signal. But actually, maybe not, because that would force me to change the logic on the component. So the question is, I think searching for the node name might be better. But it's kind of annoying. Yeah, they are coupling this. Oh, this is from the node itself. So this is the difference, is that because they are doing everything from the same node that encapsulates everything else, they use that node as a bridge. So that's what I'm talking about. It's like it forces you to put everything through a node. It's not very good to do composition because of the way that the engine is structured. It's- And the problem with this is that it doesn't scale very well because it doesn't. It makes it harder for to create like generic things that can be used a lot of times. So one thing that I could do is I can create a variable on the class there that has a string name, which is going to be the name of the node. And then based on that, I can select a functionality. Yeah, so that's what I did on the icon sidebar. Like The thing that I'm not really sure, like probably this is gonna happen all the time, and this is probably the way that I'm gonna solve all the time. So this is kind of the problem because if you put everything based on the name, it feels kind of weird. I'm not really sure if it's gonna be very good, like if it's scalable, but maybe it is. I think that this is always gonna be the pattern. Whenever you want to do composition on Godot, you're gonna have to connect things through signals, and then you're gonna have to search based on the name of nodes. Then the functionality has to be based on the member variable. You change the like you create references to like create a pointer to the other nodes that is based on the name. So you have the name of the node and the node pointer, and then you search for the node on the roots, and then you make sure you check to see if the node exists on the tree. If it doesn't exist, you throw a message, like a print a message. And if it exists, you do whatever you want to do on that node. So let me think about this. I think I'm gonna, because I can't really, maybe I should get to the point where I have the, like a selective file. It's gonna be this. I was in the first part. And I put this stuff here. But this is gonna call the display server, I think, on the window. Yeah, I remember this the first time that I saw. So this is the thing that makes the pop-up there. That is gonna show the file dialog. So so this comes from the editor file dialog. So now it goes to the action press on the file dialog. I'm gonna press F5 to see if it's gonna, yeah, so it gets to the dialog action. So whatever you put on here is gonna be what runs after. So this one is the one that creates the pop-up, I think. And then here you determine what happens. So the question is how to design this function here. I think I should get to the point. I should just define the function and then I'll think about later what is gonna happen because it's gonna depend on the other stuff that I put there. And then the first thing that I'm probably gonna put is just the file system doc. on the place that is gonna show whatever you have on the icon. And then I have to think about like what is gonna happen. So I have to first study the file system docs, see if I can implement the way that they have there. If I can't, I have to change. Then based on that, I decide what's gonna happen. I think that's gonna be. I have to do the other stuff because that's. But probably what I'm gonna do is just like probably select. I'm gonna have to think about a standard name to use for the components. So it's like set the name of the node should be that the pattern, and then do the logic based on the name of the node. That's the only way I'm gonna be able to get the node from the scene, from the root of the scene, and then change the states of the node based on the other class because they are decoupled. But it is kind of annoying. So if I do this all the time, I did this on the icon sidebar, but I think it's the only way to do it without having to change everything on the engine. The problem is like if you do this all the time, then it's gonna increase the chances that one is gonna force me to have unique names for everything, and then it's gonna increase the chances that I can't or I forget to put the name of classes or nodes when I'm creating a scene. I guess I can do it from the construct. I can change the constructor of the node so that it always has that name. That might be a good idea. So whenever I have a node that requires a pattern, I just set the name inside of the constructor of the node. That might be like a good compromise. So another thing that I have to do is go back to using a panel there. I'm gonna I'm gonna see if I can compile. And then I'm probably gonna stop. I'm gonna have to spend more time thinking about it. I think that's not the best time to think about this because I have to solve the other stuff first. But it's gonna be kind of hard to think about. And because every time that I add, I don't like very much because it's not very flexible. Every time that I wanna add another dock on this thing here, like another thing, and I wanna couple the functionality with the pop-up menu, I'm going to have to specify a unique name for that, and then change the functionality of the class to use the unique name, unless I can think about something else to do. Already using a panel here. It was because of the minimum size. Yeah, I stopped doing, I don't know, this does have a minimum sign. Okay. I don't know why it's not showing the backgrounds of the, but I do remember I changed something, so I'm gonna have to see from the editor how to change. Because I think even when it's probably the, like, I have to fill the, like, this stuff here. This is probably false. From what I remember last time, I think this is false. I have to change the name as well. I think that even if it works, it is a problem to use the editor file dialog, so I should probably change. Because if you build, like, the level the check that I have on the module is for the scene. So if you build the thing only with the scene nodes, then the build's not gonna have access to the editor, and it's probably gonna create a dangling pointer, I think, or it's gonna crash when it tries to, or complain about this. So, but if I can compile like this, then I think that's probably it's better to just change the name and just register as part of this, which is the same thing that I did with the editor spin slider. So you just put BM here instead of editor, and just register as part of the module, because that's going to be a lot less work. And I think that this has, I might have to remove some stuff, but it's going to be a lot easier than doing everything, I think. So after I do this, then I'm going to focus on the file system doc. And I'm not going to think about other stuff because then I'm going to go back to the assembly stuff. So, like, yeah, in the beginning, just I'm gonna let one option, which is gonna be the icon with the file system doc, and then one option on the menu there. And then in order to continue developing these classes, I have to figure out what I'm gonna do on the simulation thing. And then I'm probably gonna go back to assembly. So I'm gonna go back and forth between them probably. So I think it is working. So yeah, let me. I'm just gonna open and see what is happening with the thing there, with the this panel. Yeah, this is gonna be an issue actually. Like I have to set the name outside. This is annoying. Oh, actually not, because it's a different thing. At the power system dock, I can set the name inside. I was thinking that the file system and this class here would be the same, but so the thing that is weird is this is not showing with the background there. Yeah, so this is the reason why I thought it's because it doesn't have a size there. Oh, it doesn't have a minimum Y. But I think it's because of the thing. Hmm. Yeah. So I think it is like this because I didn't run again. So yeah, I compile here, but I didn't have to run with the thing. Yeah. Also, it worked, I think. Yeah, now it works. Nice. So I'm gonna see where I can put the class there. Nice. And this is a problem. I guess it's because of the size of this stuff here. Hmm. So like there is a problem both with the margin. It's like yeah, it's not very good if this is like right on that thing, but it doesn't like it's not that hard to solve these things, so it doesn't matter that much. Like the reason why this is happening is because the scroll container changes the size, but the stuff that is inside of the scroll container is gonna have a static like size. So I think one way to solve this is just to change the background of the container, or I can update the maximum size should be, yeah, but yeah, maybe it does make sense to update the maximum size should be the same size as whatever it is there, but so I think here is always the same thing. and puts the elements on the other side. And so it's, but obviously I don't want to be exactly the same as this. Just using it as a reference to understand. Because I think what they're doing is pretty similar probably, but it's kind of it might be different. Because this VS Code I think is built with Electron, so it's probably using CSS or something like that here. So I have to think about which way makes sense. I think it's gonna add on here. Okay. So what I have to do there on the code is add this there. Ah, nice. So when I was doing this outside of the class, the reason why I wanted to do a class is exactly because of the tooltip. So if you initialize the menus outside of the constructor and you connect them outside, based on the way that I'm doing there, it doesn't show the tooltip. And now it's showing, which is nice. Yeah, nice. Obviously, I don't care that much. Uh, I did put show up in the file, so there's something going on. So it's probably because of the editor file dialog thing. Yeah, editor settings. So I have to change the functionality of the class. What I'm gonna do is just change the name of the class and I'm gonna remove a bunch of stuff, I think. Or just enough of the stuff that I think I'm not gonna need or to make the class work. And the other thing to do is just to add, but that's gonna be outside of the class. It's like add margin and stuff like that. Probably here as well. So before I add this container on this one, which is happening here, probably gonna create a margin container and then append. But I'm not concerned with these things because they're easy to do. The most annoying is the file system doc. So before I do anything here, it's better to change the file here and then check manually. And then after I know that it works, which I'm probably gonna put on the same folder here. So I'm just gonna create another class with the same stuff here, just change the name. And see. The problem is I'm gonna have to change a bunch of things, I think. Because they probably have, it's gonna depend on how many things from the editor they use on this one. Which I guess I'm gonna see when I try to change. So I'm gonna stop streaming now, and yeah, I'm gonna do this probably next time that I stream. I'm gonna do this because off stream now I'm gonna focus. I'm going back to the assembly stuff. Yeah. So see you next time.